3, 2, 1, now. good morning. I'm Martin, I'm the CEO of Hillside Technology. You will notice it says Hillside Technology up there. We're the technology arm of bet365. We're the company that's actually buying the Basho assets. So you may hear this name bandied around a little more. We've just started a Twitter feed, which is, I think, bet365 technology. Yeah, so if you keep an eye out on that, you may find interesting things appear in there. So I'm not going to kill you with PowerPoint, because obviously it's very boring. But there are some things on here that I didn't want to just remember and read out to you. Okay, do you want to pop on to the next thing? Actually, pop back. I think we need to introduce each other first. Do you want to go around and tell me who you are, Martin? Go on yourself.
Yep, I'm Martin from bet365, working in middleware, focusing on RIAK over the last few months. Yep.
I'm Raman Sen from NHS Digital. We use RIAK quite extensively in Spine, so I run the operations team, and I've also been working on fixing our pain points with it.
Yeah, I'm I'm a technical lead on NHS Spine, working for NHS Digital.
Brian Hunt, former Basho, now working at ESL.
Eric Nielsen. I currently work at Club Collect as a software engineer.
I'm Andy Richards. I work in R&D. I'm from bet365. Heavily involved with RIAK and interested in some of the directions that we can take it.
I'm Alejandro Romano. I'm CEO of Flipside, and we do products and solutions based on RIAK Core, and we use RIAK KB and RIAK TS as well.
Steve Roberts from Airlink Solutions. I'm more commercial than technical. So obviously we've got a vested interest in RIAK because we've got customers using it. Great to see this company.
Russell Brown, used to work at Basho and bet365, and now independent RIAK consultant working primarily with the NHS.
I'm another Martin. I'm Martin Sumner, and I previously worked on the NHS Spine programme as a technical lead, and over the last year or so I'm also now working as independent consultant on RIAK, but primarily for the NHS.
I'm Jean-Paul Payon. I'm working from KBAW company in France. We have been using we are using RIAK a lot, TS, RIAK KB, and a fork version also, and we're interested in contributing again. And then I'm also chairing of W2, which is an open source organization hosting an open source project.
I'm Mike Gruff, formerly lecturer at Keele University, which is a local uni, and I'm not used RIAK, but I'm very interested in different data architectures and their impact on methods, system development methods. I was involved a lot in the 80s in Jordan methods, and subsequently doing consultancy in research and development of methods of finding requirements, particularly.
Hi, I'm Dan Sagney, work for bet365.
Good morning, everybody. I'm Darren Waters. I'm software architect at bet365. I work in the middleware area.
Okay, what I would like to say is first a couple of things. Thanks very much for coming. It's really, really appreciated. I know we're in the middle of nowhere, so you know I do appreciate you making the effort. The other thing is, I have to say I'm really impressed with the fact that the NHS have adopted open source software. I think it's fantastic. You know, I mean, I hope it makes its way into the rest of the government, because it will save us a lot of money, and I think we'll end up with a much better system. Okay, so I need to put my glasses on now. Yeah, you can go on to the next thing. Right, so I've only got 4 slides. The first 2 are just telling you what's in scope for this. So these are the products that constitute Basho's IP. I think you should be familiar with pretty much all of them. I don't know if everybody's familiar with the Marks product. We've got some explanation of that here, which I will read out. It's an IoT-based product. And it was one of these things at the point where Basho started to pivot and try to get into IoT and time series and so on and so forth. So it's basically React TS and other popular open source technologies for building IoT and big data applications, including Mesos, Spark, and Kafka. The rest of it's fairly.
The Q stands for Kafka.
Fairly solid. Sorry?
Does the Q stand for Kafka?
Yeah, probably does. Probably does, Russell. Yeah. Going to go on to the next one. And then these are not products, but they were in development or in proof of concept. Obviously, Russell's big sets, and then yeah, the rest of the stuff is fairly self-explanatory. E-level DB is a backend use with React TS for time series, and it also includes all of the trademarks and the domains and the mailing list and so on and so forth. In essence, it's everything that compromises Basho's assets, excluding the customer support contracts, okay? Which obviously we didn't want those. Okay, so going on to the next one. Right, so what happened with this is, I'm going to go over and give you a little bit of history for this. But one thing that came out is it ended up on Hacker News via a website. And overall, the response to the announcement that we were going to buy this and open source it was very, very positive. But we had this one comment by Michael on Hacker News, and he asked some good questions. And what I wanted to do, because I thought they are good questions, is I wanted to answer them and to explain why we're actually doing this. And then once we've got that out of the way, we can get on with Andy's stuff and with the stuff you're actually interested in. But historically, you know, we grew up with a very traditional SQL-based stack. I'm not going to talk for ages on this, by the way. We grew up with a very historical SQL-based stack, and we were growing week on week 5 to 10%, and you know, our scaling problems over the years became quite significant. And then back, probably somewhere in the region of about 8 years ago, we started to adopt some NoSQL technologies. Specifically, we were using the distributed cache, and we had problems with it. It worked for the most time. It worked okay. For the most part, it worked okay. But when it went wrong, it really went wrong. And in I think it was 2010, we spent about 9 months evaluating all of the technologies, all of the different products in this space. And out of them all, RIAK was the one that worked best under failure conditions. And in 2012, we adopted RIAK in production, and it worked extremely well for us. We did that in a small way. Yeah. So obviously, Basho were quite pushy in terms of trying to get product out, and we were adopting more and more RIAK. And in December 2014, we went into an enterprise agreement with them, which made us Basho's biggest customer. We spent several £1 million effectively for an enterprise agreement with them. And following on from that, we continued to deploy RIAK out. It worked very, very well for us. And clearly there was something not quite right with what was going on within Basho. This court case had sprung up between former directors and current investors and so on and so forth, which may or may not have influenced their ability to sell their product. I don't know. It's difficult to say. But clearly, they were not making the progress that everybody thought, that I thought that they should be making. And in September 2016, we were approached by them asking whether or not we'd be interested in investing in Basho. Clearly, they'd had difficulty trying to attract further series of investments elsewhere, and they were looking for a very chunky 8-figure sum, more than they'd ever attracted before, to keep them going effectively, to try and get time series up and running, which is where they thought the future was. we were open to the idea, and we looked at their financials, which they shared with us, and quickly came to the opinion that this was not a going concern. At that point, we started to get very serious about our own internal capabilities around RIAK. We were already in a situation where we could support RIAK without Basho's help, and in fact, we found issues where we'd seen bugs in RIAK and we'd found the bugs before Basho had found the bugs. So at that point, we started looking very specifically at replication, which is something that we're very, very invested in here because we do a huge amount of it at high volume. So that was September 2006. Things carried on going downhill, and in March 2017, Basho effectively went quiet. They approached us, and initially they approached us asking us whether or not we'd be interested in an acquisition. And now, I don't want to go into all the details of that. Suffice it to say that the numbers that they were putting on things were unrealistic, and we declined to participate in that. They subsequently came back asking us if we were interested in the enterprise source code, and along with a number of other companies, we bought that source code because we felt that we needed to do for our own protection. And again, that was a seven-figure sum we shelled out for that. We've paid quite a lot out on this already. So, following on from that, while I was on holiday walking in the Lake District in late July, Adam Ray got in contact. By this time, Basho had almost ceased to exist. Adam Ray got in contact and asked whether or not we'd be interested in acquiring the assets of Basho because they'd gone into receivership. When I got back off holiday, a few days later, I had a chat to Andy and Andy's line manager, and we very quickly came to the conclusion that if we could get it at the right price, then acquiring the assets and open sourcing them would be a good thing to do. So we decided to do that. The receiver was very open to it. They've been really, really good with us. And we came to an agreement over price within probably 2 or 3 days. Since then, it's been a very long, protracted process of going through the legal aspects of getting it to a state where it could go and get presented through the court. Okay? So the thing was, and one of the things that Michael asks in here is RIAK so critical to bet365 was the right move to buy the company versus switching to a different storage system? The answer to that is yes. We're a large company. We have a huge amount of IT. Looks like we've got another visitor. We have a huge amount of IT, and changing to a new technology is possible for us, but the amount of work involved in it would be significant, and we don't want to move away from RIAK. We think it's a really good technology. I'm really passionate about it. I think it's a brilliant technology, and it works, which is a key thing for us. And to put it into context of what the size of our IT systems are, is we've got over 900 people working behind technology. All they do is write software, build systems, and support them. We spend, this year, we'll be spending somewhere in the order of about £95 million on IT, which is a fairly significant sum. We use Postgres, yes, but will Postgres solve the problems that RIAK solves for us? No, it won't. It won't. Okay. So, things have been slow, primarily because Basho are a US company, we're a UK company. so there've been tax implications that we've had to look into. We've had third-party tax advisors involved in it. We've had third-party legal people involved in it, and all lawyers do, in truth, is slow stuff down. I mock them endlessly over it. They've worked really hard on it, but nevertheless, trying to get legal agreements in place is very complex. The issues around the outstanding support contracts had to be taken into account, and there have been a whole bunch of things that have been going on regarding other companies wanting to buy the source code. Now, the interesting thing about this is that we said we'll buy the source code for this and we will open source it. We'll buy all the source, we will open source it and engage with the community on it. Other companies, quite rightly, other companies were approached by the receiver and asked whether or not they would want to buy the source code for their own use. With our permission, we were asked by the receiver if we were okay with that, and we said, well, why would anybody want to buy the source code for this? Because we're going to open source it. Now, obviously, that's us saying that we're going to open source it, and there's no legal statement in there that it's definitely going to happen. But you know, obviously, when you start publicising these things, you're not going to back away from it. But at the time, that wasn't the case. Other companies did buy it. We were okay with that, as long as they were told that we were going to open source it. It wouldn't have been right for the receiver to sell on the source code to other companies when they didn't know that it could be available for free at some point. So other companies bought it. That all had to get encapsulated within the agreements, and we finally got the legals agreed on the 26th of September after a huge length of time, and that was all done and dusted, and we then got a court date of tomorrow where everything's going to go through the court. We hit some snags over the last 2 weeks, and particularly this week where we've had to modify things, but the good news is that everything's going through to the court tomorrow, and I think, all right, dude, everything's going to the court tomorrow, and I think it should go through pretty straightforwardly, at which point everything will be done and dusted. So I think that's pretty much all I wanted to say, really, other than the fact that I'm not sure if it's a good or a bad thing that Basho have gone out of business. On the one hand, you know, having everything open sourced, I think, is a very positive thing. But on the other hand, it's been a little bit negative in terms of the effect it's had on the community. I think that Basho had a really good reputation in the early days as a technical company. I think their attempt to pivot to try and get this exponential growth really was the downfall of them. You know, we did say at the point when they asked us for investment that we thought they should really scale back on things and just try and concentrate on keeping the core business going. But obviously investors are looking for those big returns, and they pushed for that, and in essence they failed. But coming out of that, the bonus side of that is that we're going to get, you know, everything open source. So I think in answer to Michael's question overall is the reason we're doing it is because A, we don't want to move away from RIAK. B, we can afford to do it. You know, we have a very large IT budget. And C, Andy, myself, and other people in the company, we're really passionate about the product. So we want it to succeed, and we want to make it a success going forward. And I think the best way of doing that is to open source it. Okay, that's it. I'm done.
Thank you, Mark.
I'm going to leave it to you now.
For the basically for the rest of the day, I think what we want to do is really, it's up to you guys to set the agenda. I think we've got a bunch of points that we want to go through. I think if we can agree, that one there. So we've got a bunch of points that we put about, that you should find the hard copies around the room. Bunch of points that we really want to talk about. If there's anything else people want to add to this list, if you can shout it now, and we'll get it added on. And I think the plan is we'll put some priorities on these and an order. We'll set that order, and then we'll break for coffee, come back, and then we'll just get into it. If we need to move that way or
yeah, it's like the one thing I'm not seeing there is like continuous delivery system or some type of automation around that, like Travis or whatever.
Okay.
Just going forward, so you get like builds pumped out on every change.
Yeah, yep.
And testing as well, quick check.
Yeah, I think test. We've got testing on explicitly. Quick check. I'm going to leave you now, guys. I will pop back various points over the time, but the other thing I would say is, if there are any questions that you want to ask me or anything, you just let Andy know and he'll come and grab me, and we can have a chat about it. All right. Again, thanks very much for your time.
Thank you.
Thank you. Is there anything else?
Is airline OTP upgrade more recent releases? Is that what that means?
Yeah, because we're on 60.
Just checking the.
Is there anything else that anyone wants clarifying on that list? Or anything else that's missing? Come on, speak up, Brian.
What is
it? Go on.
No, we're just talking like a lot on the train last night, just about basically just amputating bits of the code and just reducing the amount of the code base, and obviously there's also chucking out some components as well, like Erlang JS, the React control. There's a couple of components that are just nobody ever uses. The old React search implementation.
It's going to be contentious, isn't it?
John uses it. Did? You using the old React search? Well, that's kind of the point of it, is to find out if there is actually anyone using it. Some of these things I know from working with Basho, that no one actually ever paid for support on a lot of things.
Right,
So
but it turns out that you have a fork of React search.
So for the search we have integrated Solar a long time ago, and yeah.
I'm not talking about the Solar one. I'm talking about the legacy search.
Yes, but on top of the old version, I don't remember the one from we have integrated a Solar-like API. We are using now, and our application are stuck on this version because there's a little difference with not integrating search engine. So we are interested in migrating to unified, the mainline version of the search engine, but once it's stabilized, we are sure that they'll be stable.
But I think Yokozuna and React Search is a big kind of thing, because it's a big bit of React, and sort of until John mentioned his use of it, I don't think I was aware of anyone who was using it in production either. Are Intel using it as well?
Intel or not? They're using Yokozuna.
They're using Yokozuna. And we're talking about the old merge index React Search pre-Yokozuna.
But I think Yokozunas are worth discussing as well, because that's a large part of React, and should it continue to be part of React going forward?
I was actually referring to the old React, the merge search.
Shall we just put search on that?
It's on the list, yeah. Sounds like it, Andy.
So yeah, we were trying to get on like Slack, get some information from people about, what if we killed this? And just like see does anyone like start screaming?
Yeah. But the point I think should be, do we need indexing?
Okay.
And if we need indexing, what is the right solution? Because obviously I'm using Solar at the moment, and I don't like using Solar at the moment because I'm using the Java stack on top of the hybrid. I would have liked that to be pure Erlang within as an option within the app.
That was what they tried the first time around, but they couldn't reach feature parity.
Yeah.
And then let's just
shortcut that.
Outsource it.
Martin, you sent me a bullet point of things that the NHS might want to take a look at, which take their P20, building release, etc. Is there anything else you want to
or anybody want to add?
No, I think the other things that we're probably going to talk about are going to come up in other items, in that we've also been thinking about different approaches to indexing, but within RIAK itself. So I think we have a general discussion about indexing, querying, and so all of that will come up. And particularly when we come to talk to replication, obviously we've been doing, originally we didn't know that enterprise replication was going to get open source. So we've been building a number of things related to replication. So Russell's been writing Rabl, a replacement for real-time replication, and I've been working on alternatives to Fullsync replication. And I think it's probably worth talking about those when we discuss replication, about actually is there value in them as an alternative to RIAK Enterprise, even if RIAK Repl as it stands is of open source. Are the things that those replication items might do better? Because we're hoping that they're potentially simpler, and I think we're also hoping that they can resolve other problems, in particular ring resizing, which is a big issue because there was ring resizing exists as a feature in RIAK, but with this big asterisk next to it saying don't do this unless Basho come and pray with you and whilst you're doing it, and there's no Basho to come and pray with us and do a rain dance and whatever it is they did to hope that ring resizing works. I don't know if you ever, Ryan, were involved in any ring resizing when you were.
We did here. It was pretty brutal.
Yeah. Well, that needs to be its own topic, because one of the ways that we're trying to resolve that is through multi-data center replication. So if you can replicate between clusters of different sizes, then although it's expensive in terms of infrastructure to stand up a new cluster, then potentially it's a much safer way of doing it, and we probably take short-term cost over risk when it comes to having to do that.
Yeah. This is also a critical point for us.
I think Martin mentioned there, we use replication a lot. We replicate a lot of data. So one of the reasons we've got we've got internally, I think Martin and Dennis are working on is the tactical pieces of patching up. I'll use that phrase. The current replication, but we want to move to something that's simpler and more robust, easy to understand.
Under the enhancements, and I think this is not something that we should tackle right now, but is it anybody interested in transactions, such as in pure CRDT base? The multi-key atomicity.
I guess we might have some interest if we think that's possible. I guess probably our initial thought on that is that's kind of too hard to prioritise over things that might be simpler to achieve. I don't know, Russell, if you've got any ideas about how hard it is.
No. Yeah, I mean it's probably hard, but people have done it, haven't they?
Yeah, well, antidote. That's it.
The systems do it, so it's not impossible. But usually has to be use case that drives the feature. So internally, when we talk about indexing, we're talking about having separating indexes from objects. It would be nice to have. It would be nice to have transactional writing of indexes for that, but not essential. You can work around it without it. But if it's something that's easy, relatively easy to achieve. A lot of features are going to be driven by the current users, aren't they? A lot of current users of RIAK probably live without transactions. Probably why they were able to choose RIAK, because they probably live without it. So that was more of a case of prioritising than like technical ability. I think it's technically achievable. We've got a big list of where to go.
Actually, we need transactional operations to use alternative solutions. It's not a priority because I think that many people using transactional operation that cannot use alternatives.
But it's worth talking about all of it.
And I guess one general thing that we've been pushing for as well is to get an idea across existing React users about object sizes and cluster sizes. So obviously in the past Basho we're trying to do a lot of stuff about how do you expand beyond kind of 40, 50 nodes and that kind of stuff. If no one's as an existing customer needs to do that, then we can kind of forget about the stuff that was driving them in that direction. And then the other things for object sizes, from an NHS perspective, we have relatively significant sizes of objects, generally speaking, 8 kilobytes or bigger, and this kind of stuff. So we tend to think a lot about optimizations with larger objects and problems with very big objects, when things grow to become megabyte objects and that kind of stuff. And I guess what's of interest to us is across the community, it's everyone else working in a similar object size, so if we're optimizing for that, or if we're optimizing that, are we going to be hurting a bunch of people that have 200 byte objects and they really want to scale out with much smaller objects?
Maybe like trillions of advertising beacons or something.
Yes, a lot sort of implicit in what Martin says is that there's React as a product built by Basho was built to serve lots and lots of very diverse set of customers. Some of whom will have been the biggest customer at the time before Bet365 came out. And what they wanted probably set the agenda for development. So that would be maybe because the people were very interested in lots of small objects or that kind of thing. So the direction React's gone in has gone in lots of different directions for lots of different customers. And now there's a smaller community now, let's be honest. So lots of people have left React because of what happened with Basho. But those who are left are more keenly invested and know more about how they want it to behave operationally and what features they want.
Yeah, and I think there are some general principles there. That I think the reason why NHS uses it is very similar to bet365 in that availability is everything, and operational efficiency. So we want to be available. We don't want to be highly available whilst requiring an army of people to maintain that availability and lots of bespoke hardware and complexity and that kind of stuff. We want high availability in a very simple way, and we definitely don't want to ever lose data. So losing data is a real big thing for us. And kind of like median latency can be higher than in other database systems. It doesn't. The difference between 10 milliseconds and 5 milliseconds doesn't matter to us. And it'd be good to get. Is that a general consensus around React users? Because people tend towards React when they've got those, when they desire those characteristics, or are we different to other React users? And it'd be good to know that when we start prioritizing from a general principle basis. Are we all in the same place? And I think historically perhaps Basho tried to compete with Cassandra. How can we do what Cassandra can do with small objects and very, very large clusters and this kind of stuff? But if what's left post Basho is the people who've chosen React over Cassandra, then perhaps we don't have to compete with Cassandra anymore because it doesn't matter what benchmarks Cassandra produce because we're not actually seeking out to grow into and overtake that community.
Okay. So I've added those items. How do people want to play this? Do you want to vote on the whole list, or just pick the first thing to talk about and then move through piecemeal?
I think pick the first thing to talk about and then
okay.
I'll go for that.
People are pretty excited about search and indexing. I think
people are conflating it as well, because there's the full text search and then there's just secondary indexes. So it's important to know.
They often, the thing is they are conflated, aren't they? You have a choice, and sometimes which one you pick is based around how much time we're going to invest up front versus how much time, how creating a big. So I think they're conflated in the same area, aren't they? Which is non-primary key access.
Well, I mean, the storage backend is providing the secondary index, and then like the co-processor, be it Solr or the merge index stuff, is providing full text search.
Storage backend.
Isn't it so?
Yeah, that's how it works. It's another storage backend.
Yeah.
And then a partition scheme. So even implementation-wise, they're so.
Yeah, but I think the two different concepts is, you know, we face a decision about do we grow secondary indexing and other indexes features, so we increase towards, we're not never going to achieve feature parity clearly, but do we increase the functionality there, or do we work on the assumption that they'll in the future everyone will use an alternative indexing function. And I guess Basho were kind of moving towards the latter, weren't they? They were sort of, you know, saying negative things about secondary indexing and this kind of stuff.
That
you know,
was driven by the fact that like the main level DD developer, MVM, he left the company for a while, didn't he? And then at that stage, their strategy changed based upon what technical resources they had available, rather than kind of strategically based on needs.
But I guess, Andrew, we're fulfilling your prediction at the moment by finding indexing and search interesting.
I wonder if the most important thing, though, you've got things like, you know, code baseline and state of the union.
Okay, so what might be more. All right, and what we can do is, if we can talk about the things that will get the code out there, which is a baseline, licensing. After that, the code's free, isn't it? Yeah. And then from there, we can get into the future developments and whatever.
Yeah, so we can all kind of say, how do we use RIAK as a baseline, and also what are we currently working on? So what are we producing, what we've nearly, what have we got ready, and that kind of stuff.
So pick an easy one then. Can code be released without removing GPL, or does that have to be done before it?
That's a good question.
So it wasn't GPL anyway. There's GPL and test cases, and there's LGPL code being checked in as well as part of one of the HLL, the hyperlog log. There's a bit of C code. It's LGPL.
And is that shipped?
That's shipped. If the hyperlog log is being shipped.
Because proper is on the test code, so that I think you can take proper off the.
Yeah. So proper is GPL, right? Yeah. They said test code is fine, but if you actually, well, I noticed in Basho they had a tendency to not have like one module, the test module, and then the module for the implementation. If the implementation and the test case is embedded inside that module. So
it doesn't matter. The test case might be, but we don't. The test case depends on the library proper. We don't ship the proper library. Okay, it's just source code. You don't ship proper. So I think proper is off the table. But this C array thing, is that actually shipped? Is that shipped?
yes, it's shipped. It's LGPL though, so you know I'm not sure what the implications are. LGPL has got a linkage license, so you can link into it without contaminating the code. But
without having lawyers here, that probably we don't have any lawyers.
Does anybody actually use that bit?
Nobody takes it out. No idea.
That's a good question.
Because if nobody's using it, then turn it off, take it out, and then put it back in when you can get rid of the GPL stuff.
I think that's what we discussed the other day. So we should just take it out if no one's using it, and if someone wants to come and use it, they can take on the licensing problem in the future.
I think as well that the library as well, the HLL like C implementation is just a small group of people who have had communication back and forth with Basho before, and it's a question of like maybe you could cross license it as Apache. There's only like 2 people who worked on it. You can easily reach consensus, and then we could include it at some point in the future. But like really, you get more benefit, i.e. publicity from it, than we do because who's using it anyway? Yeah.
Okay, so is that the consensus? Take it out, engage with the developers, put it back in.
Yeah.
That is what taking out is proper as well. So, like, the question
No. It's not used in any other projects, is it? It wouldn't be, well, it's debatable. So the proper guys were like, on the issues, or on a mailing list or something, semi-informally, said there's no issue if you're just using it for testing. But they declined to make that explicit in the license file or README or anything like that. It's actually in the Git repository. So they left it free of ambiguity, just risk.
So what are you guys using QDQ as well? Quick check.
Quick check is used, yeah. I don't know why proper was used in that particular. What was it used on?
Proper is just a dependency of the HL library.
Oh, is it? Is that?
Okay. So HL is
Ah. Right.
So take HL.
Excellent. I suppose the next question is which license to release the code under. I think there was a general discussion on the React users mailing list with it seemed to Apache 2 seemed to come out on top. Excellent. I think that is enough. Actually, no, I think it was something that Brian brought up in discussion a few weeks ago as to where to baseline the code. What is the general concern? Because I think you raised concerns about what do the final months of Basho mean in terms of commits. What do we want to do about that? Do we want to look at where we are and review the last bunch of commits, or just wind it back and baseline it?
Well, I mean, you mentioned you use time series, John.
Yeah.
Did you?
Yeah. The vanilla version.
Okay.
Yeah.
Alright, so what version of React is that fully merged into? So they did towards the end, because there was 2.2.3 was the last stable release, wasn't it?
Yeah.
And then what happened after that? They merged into time series code base and all?
They had a release 2.5 they were about to ship. It was all done but for the shipping, because there was an argument about naming, whether it was called 2.5 or something else. I wasn't there to watch it. There were others maybe who were online, like right to ship, might remember better what happened. So there's a bunch of code that was technically ready to ship, but haven't reviewed some of that code.
Yeah, I mean, we've been starting from 2.2.3, and the stuff that I'm aware of that was kind of ready to ship for 2.2.5, and that isn't in 2.2.3 is there's some code refactoring called RIAK KV requests, which effectively wraps some records in a module, and it makes the code quite a bit easier to read around parts of it. So, a relatively low risk thing that has some value in it. There was probably the biggest part of it was RIAK KV sweeper, and so I've done some testing with RIAK KV sweeper, and it definitely seems like a sensible idea. So the idea behind RIAK KV sweeper is that we've got things going on at the moment, in particular hash tree rebuilds that need to go and roll over, do a fold over all the objects. So the idea of RIAK KV sweeper was that, well, maybe there's other things that you want to do when you fold over the objects, other functions you might apply, but rather than do it as lots of different folds, why can't you queue up functions so that next time you do a fold, it will also apply the same function as well. And I think that was then seen as a precursor to being able to provide more stats around, how many objects have I got in my store, which obviously React can't tell you at the moment, and what's my average object size and all of that kind of stuff, is that you could have some kind of stats fold, and then next time you had a scheduled fold for some other reason, it would also apply that same function as well. The other thing that RIAK KV sweeper was doing, from what I can see, is that like everything in React, there's about everyone's got its own way of throttling itself. So RIAK KV sweeper introduced a new way of throttling stuff, and to make sure that there's not too much of that fold activity going on concurrently in the cluster. Based on the limited testing that I did, it seemed to be very effective at that. So it has a throttle so that if you're reading objects too fast, it will slow down and this kind of stuff. And you can set some rates at which you will read and this kind of thing. And it has a throttle to make sure there's not too much concurrency going on across different nodes and that kind of stuff. So it all seemed like a relatively sensible thing. But we did some testing with it, and I did a change to it, and in my change I introduced a bug, and when my code crashed, the KV sweeper crashed, inevitably started again, and so KV sweeper died in the cluster, and I think there was I think one of the original Basho developers commented that there are some things they still haven't quite looked at in that code. It needs some more robustness checking before it goes live. So it's a reasonable idea. It's a good idea. And it's not quite there yet. And one of the reasons why we've not put too much focus on it is that it actually overlaps with other things that we've been looking at. And in particular, we've been trying to make the job of doing folds much easier through alternative backends. And I've also been looking at what we call the core node worker pull, which is a way in which we can more generally throttle background activities by saying, rather than having an open and almost endless vnode worker pool that we got at the moment, having a single a constrained number of workers per node rather than per vnode for doing this type of work. So for us, from an NHS perspective, we don't necessarily see KV sweeper as necessary in a future where we may well be changing backends and using the core node worker pool. But there's definitely value in it if you're sticking with level DB and you want to do this stuff going forward. But I think most of the value will come when people start writing new sweeps for sweeper. And I think at the moment the only sweep for sweeper is the one to do the AAE tree rebuild. So it will kind of, it's a platform that has nothing added onto it yet. And I don't know quite how it fits in with another piece of work that was on developed that I don't think was slated for 2.5, which is a new job management for RIAK core that was being worked on. I don't know whether that overlaps in some way with KV sweeper as well. So our starting point we've taken so far is RIAK 2. Is RIAK 2.2.3. 2.2.3.
That's the last known good. That's released and people are running it.
And mainly because we've probably got other ways of resolving. We're looking at other ways of resolving those problems.
Or we can bring that code in.
Yeah.
But what feels unsafe to baseline on something like that, like Martin's saying, a small audit of that code has led you to issues. So there's 2.5 or 2.3, whatever it's called, is developed 2.2. So it's always unknown code. You can times that by 52. So 52 dependencies for RIAK. Although we'll probably most concern those big ones like KV and Repl. But from a point of view of like who has the will to review all that, I think it's more likely to make sense to baseline on a known good, and then things that we discover in development without 2.2 can come without the risk of starting from there and trying to fix what that should fail to ship.
So we're saying 2.2.3.
That's what we've been. I mean, that's open for discussion. But my argument is picking something that hasn't been released is probably answer.
Yeah, no, I completely agree.
Especially which release one.
So then what you do is like you base develop up 2.2.3, cherry pick, create a new feature branch for moving the sweepers directly into it, cherry pick those things into that feature branch, see if it's viable, and if it's at every stage going to get merged into develop, and then be the way to move on.
And I guess at the moment is that from the NHS perspective, we're not prioritising work to look at KV sweeper. We're prioritising other ways of kind of resolving some of the problems that KV sweeper was trying to resolve. But that might not be the same for everyone.
If the original authors of sweeper, like assuming that it was just like there's a job, go implement this, if they still remain enthusiastic about it and they have confidence in the code, would you get involved at some point in the future and help to get it in?
There's licks and strands for work.
Yeah. So
He's
crack up.
the original.
Yeah, and yeah, I've had responses to Git issues and this kind of stuff from ex-Basho developers. So you know, they're definitely not turning their back on it. You know, so but obviously, you know, other people have other jobs now and this kind of stuff. So you know, whether they can commit to doing stuff, I don't know.
Okay, that sounds good. All right. So I think with those. With that general, well, with the consensus in the room on those 2 points, I think we're in a position where we can actually release something. So, what, in terms of moving forward then with the developments, what I'm hearing this morning is indexing is a big thing for us. Replication is certainly a big thing for us. Do we want to pick one of those two and get into it?
Just before we do that, can we talk about also kind of getting to the point where we can actually build something? So CI.
Yeah, no, it makes most sense.
And that kind of just finish off the kind of code base side of things. So from our perspective, we definitely need to get CI figured out. Russell's done a lot of work on doing React tests. No, sorry, the make test function.
Yes. So currently, if you check out React, even if you check out React 2.2.3, you know the shift branch, you run make tests, then you can get failures. So we don't. Although we have like this known good thing that's been shipped, kind of known, like a known bad. You know, we know it's okay. People are running it in production, but we also know that there's tests back. So I've spent a couple of weeks getting those to pass. Most of them, there's no real. I've only found one what I would call bug, and that's in side job, and it might just be the side job's designed that way on purpose, because the information's gone. The author's gone and they didn't write what trails they chose to make. So I'm just on the train there's one pushed in the last sort of push up to we've got like an NHS repo while we're waiting for it to come out. So all those forks we now have you can check out NHS React 2.2.5 for some reason installed. We're missing out 2.2.4 that will build. So that we think that's the sort of first stage towards CI. So then we've got that where all tests pass. And there's no changes to it beyond a couple of minor. Most of the tests getting passed is just path changes and tweaks. Okay. Tweaks here and there. There's no like bug fixes. You're not changing behaviour as far as I can tell. And then the side job thing, the only thing that's to remove a test for is if the test just doesn't pass and will not pass with that design. So then the next thing we're going to do is we've got React test, which is like the sort of more integration testing part. There's 180 tests or something slated for a release of React next week. So now we have a React that builds. The next job is to run those React tests and see how many of those tests. And that's by next week. Okay. And then when that works, then we can do CI based on that. And that we would then consider that a baseline. And then if you take all that stuff that we've done, all those patches, merge them back across to the canonical repos, and at that point, if you want to work on React, you know you can just do a git clone, make test, it passes. Now I make the changes, make test, it fails. So then we're going to say
make test for the privilege if that means like as it currently stands, bet365, Airline Solutions, and you guys, we're the ones that are the quick check stuff.
Well, there are tests. The React test isn't quick check. So once you get the React test stuff working, that's not. And the unit test stuff. There are lots of tests that aren't.
So I just think for the benefit of everyone else, just to clarify what React test is. So React test is a standalone repository, which basically you check out versions of React, you do a build of it, it runs test suite against them, and stands up like a DevRel type cluster. And then it's got some code which you can inject into the nodes to simulate various failure conditions. So that's because you've got like your ordinary test where you just check out the whole project and you just run make test and it's doing that.
There's three levels of testing in React. There's unit testing, and then there's the property-based testing, which is we call it exclusive testing, and then there's React test, which is integration testing. And And two of those three levels are open source and available to everybody. And the license for quick check is the only kind of issue. You can run counterexamples without a license for quick check. There was someone, James Gorlick, who's an ex-Basho employee, was talking about reporting the quick check tests to, the quick check CI for open source projects. So maybe that's something that's worth looking at. But for the larger community, but I think one of the arguments that we've had is that although there is a community, the majority of development work is going to be paid development work by people who work for one of the main contributors who tend to have licenses.
I was kind of hoping at some stage in the future we could get the Elixir community involved as well, because obviously they're massive in comparison to the airline community. And kind of
They have a
more.
horrible taste in languages.
Well, I mean, that's that, Davies in the eye of the beholder. Yeah, you can see that in London. But yeah, like just for wider participation, I saw it as something that could maybe, like, I think obviously quick check is vastly superior on a technical level to the alternatives. It appears that like you got proper, just the licensing, GPL, great. Everything else is Apache, and you get Trick by Preston. Yeah, and it is, yeah, exactly. So this is, I'm not saying that there's an alternative to quick check, but it's just like how we fit it in such a way that, yeah, there's a level of testing that's going around that and into releases, but it's not prerequisite to get stuff through a pipeline.
So you have like an example of this, right? You wrote a huge feature for Basho RIAK when Basho was still there for 2i. So like most people who are contributing, they'll write the code, they'll write some tests for it, they'll run it, and then they'll hand it over. They'll make a pull request, and at that point it then becomes community property. But before it's merged and committed, someone's going to have to run the larger suite of tests on it, including
of course.
And that didn't stop Mark from contributing. It didn't stop him from being part of it. It didn't stop him from writing the feature.
But at some stage, somebody ran the quick check test.
Yes,
and
but I'm saying it's not a barrier to. You're saying it's a barrier to entry. I'm saying it's not a barrier to entry.
I'm not making an assertion that it is a barrier to entry. I just think it's worth exploring it at this stage, and just making sure that it doesn't become a barrier to entry is my only concern.
One other thing on barriers to entry is we're talking about rebar CT. So I think that's one of the other things that was done as part of RIAK 2.5 that's currently not developed, is that they've started writing some rebar CT tests. Now the advantage of having rebar CT tests is that if we want other people getting involved and people with an Erlang background, it's probably easier for them to get up to speed with writing a rebar CT test for a feature than it is writing a RIAK test for a feature. So there might be some value in looking at that effort that was on developed to do rebar CT tests, to actually get some example rebar CT tests, get them involved in CI, and then if someone is writing a feature that's not, well, I suppose this is kind of hard to have an example where it's not dependent on multiple nodes and all this kind of stuff, but or maybe they don't have the time to do that. They can quickly do a rebar CT test to prove that feature works, and we can have a kind of a quicker make test that goes a bit beyond the unit tests, and also run some more end-to-end tests, but without necessarily being as complicated as the RIAK test.
Yeah. And there's a lot that you can do with CT. I mean, you can spawn nodes and create and run CTs and nodes.
That's what we were doing. The TS guys have brought some RIAK tests over to CT, and I think that's worthwhile. I think that that makes, talking about barrier to entry, that's something that makes it easier for everyone to run. If you have make test and you have make I test, for example, that will run your CT tests and port RIAK test over to CT. And I think that's probably, we're going to look at it, but the first thing, of course, is to get the RIAK test back in reliably.
Given that you're the most recent person, because I haven't touched it in a year or more, the RIAK test, how do you find the condition of that to be, and its sustainability and its maintainability going forward? Is it gone crazy complex, or is it still same?
So there are people who, like Brett Hazen, who worked on it full-time, so they'll know much better than I do about it. I've never had problems running React tests, but lots of people have problems running React tests. The complexity of running React tests is which version of React test do you run against which version of React? Which set of upgrades do you choose? Dependency problems, that kind of thing. And I think those are probably going to be solved easier if you have it in common test, because you'll be running it against a particular, the one you want to check out.
Isn't there kind of a bit of black magic with React tests? You've got to get that magic configuration file right, and no one knows how you get the magic configuration file right, but once you've got it right, you can change it.
Okay, so I kind of came into it right at the beginning. I wasn't even an Erlang programmer, and it worked straight away first time for me.
Nice, so it's just me being an
it's
idiot.
It's no confirmation bias there, right?
But yeah, I think back to what Raman's original question was. Part of code baseline, I think, is getting CI. It's getting to the point where you've got something that reliably builds, and then you can automate the reliable build.
Yeah, I think let's get to the things that we've already got, get them working, and then improve them later, because that's not kind of our main focus.
And that's something we're definitely committed to doing from an NHS perspective, and everything we produce in that area in terms of CI scripts and that kind of stuff is going to be made open and that kind of stuff. So obviously it'd be great for us if anyone else is actively working on that as well and contributing to it and can contribute to it. But we'll be cracking on with that anyway.
That was something I wanted to add to the end of the store is not processes to the level that we were talking about in the post React Slack chat room weekly meetings, but just having some kind of informal but regular conversation between those who are actively working on React. For instance, so that you know that Mark's working on a core node worker. So don't write a core node worker.
And I think
talk to him about it.
Exactly. And I think part of what we want to get out of these 2 days is where are we now? Where are we going? We've got that roadmap. Who's working on what? And if you want to go and work on feature A or whatever, speak to the guys that probably also working on that.
So some real basic process bits then. So presumably the GitHub account is based until after the court date tomorrow. When you get the GitHub account, who's going to be the gatekeeper of all these pull requests?
I think that's one thing to be discussed as well. I think from that discussion that we had earlier, it sounds like people with quick check licenses.
With manager was well, from me the first question.
Right. Who will be releasing React?
But there's a point on governance later.
Well, I think that's the next point. That's the carry on from where we were just discussing. So we've got we know what we're going to take, which is the 225, to make that the canonical repo. We fix up the tests, so we get the test passing. People with quick check license, we quick check tests, and then we're in a position where we can build. And we just automate that build, and I think we've done. I don't think it's any more complicated than that, unless I'm missing something.
Can you not save your quick check tests? I thought you could save them so they can be run in a continuous integration environment, so you don't actually have to have a license, but you have to have a license to generate a saved test.
So you can run counter examples without a license. You can get quick check mini, it's called. And then if someone has a counter example, like a failing test, you can run that using quick check mini, and then you can fix it.
So one thing you could do is build a library of these kind of examples to prove that you haven't regressed your fixes.
Absolutely, yeah. I mean, that's something I do. So one thing that you do with quick check that I do, whenever I get a counter example, the first thing I do is like save the counter example and check it in, because that's proof is fault. But often, even easier than that, is just the counter example will give you a set of commands or steps that cause the bug. You take those and turn it into a unit test, and then you don't need the counter example anymore. That's exactly that particular example is covered, and it is a unit test that anyone can then check, and it guards against regression.
Yeah, so I think it's a bit.
It's the
actual failing test.
You end up
paying
for generation.
general
What you're
test.
paying for is the generation of tests and running up those generations. But I mean, maybe we involve Kubik in the conversation. Maybe we try and move things over to the SCI server. I see it as, I know what you mean by it. It's a long-term kind of
Well,
thing.
it's just like I would love to be able to just like stick it up and traverse like hypothetically. Yeah, I know the performance is a bit slow on the pre thing, but like where you could just run the whole thing like publicly, or anyone could run the tests and run a CI, or you could chuck it into Circle CI or Travis or whatever without having to ship license files and whatnot. And that becomes complex then.
Yeah, I don't think anybody's saying don't do that. I think what we're saying is we've got a path to walk to get to that.
Yeah. That's it. It's just like finding a way where obviously the quick check stuff I think is essential, but it's a way that we can find a path we can walk where we get the benefits of both. You get the quick check, critically important, I believe, to have that in the system, but also we can find a way of managing it so we can also do builds and stuff and organize a system where we can still, every time somebody does a commit, there's some free service or open source service or whatever people put in money for funding for some type of open infrastructure, some service that we get CIs every time that someone does a commit, and we got like an artifact popping out half an hour later.
I mean, I say if there's funding issues, it can almost be, here's a script that will start now as an instance and run all of these tests and come back or anything like that.
I've done Dockerize and stuff for it already. I don't know, I want to expand on that as well.
Yeah.
I don't mean talk about or waffle about, but I want to just continue doing it.
I mean, the other thing, obviously, test cycle that I presume Basho went through before any release was to go through a set of baseline Basho bench tests to confirm that any change hasn't had an impact on various different configurations. I don't know what Basho bench tests they ran, on what type of infrastructure, and what were the prerequisites and what the baselines were and that kind of stuff. So did anything come over is anything coming over in the assets that might help with that? Is any old test infrastructure or any documentation of that old test infrastructure?
We effectively we'll be getting everything that Basho had. The one thing I will say is I'm perfectly happy to put some money into funding other things within this, within reason. So if we need, we're already paying, for example, we've already paid out money for keeping some of the websites up and running. But if we need a CI infrastructure building out, then I'm perfectly happy to fund that.
That's a good question to put out. I would say, to the community, but really putting it out, trying to hook some ex-Basho people in who worked in the performance team. What was the performance testing prior to releases? Because I certainly wasn't aware of it.
We used to just spin up Amazon spot instances and just bash them.
I think towards the end there was definitely a performance team, and it was run by this guy Eric, and they did a lot of work. They did a lot of work, scripting it and making it repeatable. So there's definitely there might be a perf repo, for instance, under the stuff you guys have picked up.
I mean we've got our own load test infrastructure, which we use intensively, shall we say. I'm happy to put something there that could sit within our infrastructure if that's what people want. But what I don't want to do is we don't want to take over doing things. We want this to be a community-led thing. If you want something that's publicly available in the cloud, we'll help with that. If you want physical instances, we can do that as well. We run everything we run with RIAK is on physical boxes.
Yeah, and they're all big clusters. Basically, when we do a release of our software, we're pushing through a load test environment, which is intense, as we know, and it's a real cluster. It's a huge physical thing, and we get benchmarks out of that. Whether part of the process will be that as part of the CI gets checked in, it does some performance on virtual off in Ireland or East Coast America, wherever. And we can take those artifacts down, put them through the load test environment, and give because not every check-in is going to be a releasable thing, is it? So when we get to a release point, we can benchmark. Well, for us to take that into our live infrastructure, we'd bench it anyway. So publishing those results is
speaking on behalf of RWT organization, we have a testing infrastructure for our projects. It's actually based, the CI is actually based on Jenkins, and we are now deploying GitLab for new projects and looking at integrating CI stuff from GitLab, because GitLab has also its own
we're using that as well.
Yeah. So actually we use Jenkins, but migrating to GitLab also maybe. We have a cluster for that. We have
there's some major issues with performance lately on GitLab, but
okay,
you can always pay for your runners, for the CI runners. So you can host your CI runners wherever you want, and you point them. So, for example, I can run Amazon instances as a runner on the fly. So run the CI pipeline, and it spawns in our town.
we have our own instance of GitLab. We don't use public instance.
Okay.
On our own cluster, we have I don't know, but 10 or 12 servers that we can give to projects.
So, you know, from the NHS perspective, from doing load testing, you know, all our load testing we kind of do with functionally generated load through the entire application stack, including RIAK at the bottom. But we've been putting some effort recently into having a kind of Basho bench script that kind of summarise roughly what happens, with the idea that then perhaps if there is someone that's owning release, that could be run as part of a release cycle, and we could get early warning if a RIAK release is causing us problems. You know, we would then subsequently test it fully in our environment. And I think there's a long list of Basho bench example scripts, and there's like a Basho bench Voxer script and this kind of stuff. And maybe in the future there'll be perhaps there could be a short list, and you know, if people are interested in publicising their Basho bench, there could be a standard set of ones whereby if you're doing something that's load sensitive and you're concerned about what the impact might be on different Basho bench customers, you can go and run those Basho bench tests, and maybe some of them can be, some of them have funded environments for running them in if
I think that the other thing there, Martin, is that obviously your use cases and your use of RIAK is very different than our use cases and use of RIAK, and people's will be very different. You know, your all large objects, got more querying going on. We're very much OLTP, you know, less objects, but volume through, and you know, everybody's going to have a slightly different use of that.
Slightly related to this, anyone using or planning to use Kubernetes, Docker, or Mesos? Well, Mesos are way there, but I've never used it. But
Kubernetes and Docker Swarm, two things I'm very interested in. Like, so libcluster is something like this. An Elixir project is changes on something like that for airline, so it'll automatically pull configuration with doing broadcast or talking to Kubernetes or you know, standard cluster setup. So you don't have to do node join, node join, node join. You just stand something up, all the nodes join in.
So we're currently deploying React, TS, and KV on Kubernetes.
So you're doing it with ugly scripts then?
They're not ugly, but I didn't do that.
Yeah.
They're not ugly. I mean, the guy who did it knows his shit. But
no, I mean ugly, but as an idea. It's a bit out of bounds.
So I'm sure that is not no way parity with the Mesos framework that you guys did. And there's a bunch of things out there, but in terms of CI, it's just a brush to work with, because you have a Kubernetes cluster out there and you say, spawn it.
Yeah, it's down.
Yeah. So we're using Tectonic at the moment, and Kubernetes and Azure, both. We deploy both there, and Packet as well. So we have three different clouds, internal to external, Tectonic and Kubernetes running that. And we're going in production in March.
With the Mesos stuff, like, do you know anything about that, Russ? You ever looked? I think I looked at some of that type of stuff, and it did seem to just like, with the Docker side, it was all just like, it boots up into a script, and then that does the configuration. Like, it wasn't like an encapsulated implementation. It was like.
I think, you know, going back to the earlier list of things, that was very much on the proof of concept side of things, rather than on the productionized RIAK. I mean, we we've got some systems running in Kubernetes at the moment, not in a big way. We're evaluating it whether that's a fit technology for us. We think it's got some areas where it could fit, of which someone was sitting on these. Whether or not we'd use it for RIAK, I don't know.
We haven't given it any real consideration.
Well, there's a question about the volumes, right? So
yeah,
you can attach ISCSI directly depending on the version you're on, or otherwise you go to the show volume. So it's questionable whether you get the same performance and reliability.
And I will say, in fairness, we've not looked at it from a storage perspective at all.
Okay.
Purely from an application perspective. But that'll be ongoing with us for a while. So but our RIAK, we're deploying onto physicals, solid state hard disks, and the big machines.
What size of clusters, roughly?
We're at the moment, we go up to about 24, and we don't really want to go any bigger than that. We're looking more at sharding rather than getting bigger clusters, primarily because the replication side of things gets a bit scary for us.
We have smaller, sort of 8, 9, 10.
Yeah, we do have 118 node cluster.
Oh yes, we have. Yeah, upstairs. Keep forgetting about that.
But yeah, generally speaking, we're functionally sharded into multiple clusters rather than trying to run one big cluster.
Yeah.
And again, we're bare metal in the world.
Yeah, I mean, as I said, we're happy to stand something up in terms of if people want to do, if that's what people want to do, we're happy to put some money into that. But as I say, people have got different use cases.
So we know that Russell's currently doing some work on RIAK tests and that kind of stuff. We've got another guy that's going to get involved in our team, hopefully in the next few weeks, to focus on CI. Are there kind of nominated CI interested people in each of the organisations? So, Bet, do you have a guy who's going to focus on CI and that kind of stuff? And is there a sort of sub-community that needs to be set up for those to keep track of, those guys to keep track of what they're doing?
Yeah, I think that makes sense to me. We've got a dedicated team basically for us to share knowledge with everybody in terms of the general roadmap and then those individual items.
And is it, in terms of people who are actively working now on doing stuff to look at testing and building of RIAK, is it just us and yourself, Brian, and Bet?
Is there anyone else?
No. You build RIAK. You build. You have your own.
Yeah, we build our own for the corporation, but we don't build it really own.
Maybe Heinz as well, but his stuff is very much for.
It's not RIAK. He doesn't do RIAK.
We use Chef. We have no infrastructure, but we are writing our own Kubernetes in Elixir. Because we use Linux containers with Chef. It was leading edge a few years ago.
Talk later about that. We should talk later
Ah,
about
yeah.
that.
Well, I'm not rewriting the new infrastructure stuff in Elixir, and we have to release it soon. And open source, that's why I can tell you right now. It's show.
Okay, then so to summarise the CI point that we were talking about, then, so Russell's working towards getting that. We'll put some names forward as contacts so we can functionally finish that off. Is there anything else that we need to discuss about getting the initial code drop, getting the builds, getting out?
Yeah, I think we didn't come to the conclusion of who's going to own the releases.
I thought we said So at this interim point, people with a quick check license would run the final.
There was 3 of us, I think, wasn't it? 3 separate companies. Who's actually going to own that release?
Well, we're definitely committing to 225, aren't we? Kind of putting our kind of small fixes in for operational pain points we have, and just getting that kind of out there for test.
Yeah, I think one of the key things, I guess, the missing all we talked about is code review pull requests. So, you know, that's going to involve some fixes that have been reviewed internally within the NHS. But, you know, is that really sufficient to make that something that's ready for everyone? And you know, so do we want to do? Is there something that needs to be arranged there for who would actually, if we're going to commit into the, you know, because that's enough to commit into our NHS repository of RIAK. For now, should we just carry on doing that, or should we actually be aiming to commit into?
Should be doing pull requests against, you know, upstream.
Into upstream, but if we do that pull request, who's going to own the code review of that? Etc. You know, I guess by default it's Hillside at the moment.
We don't. By default it would be, but we feel that if you're going to have a real community, other people need to have the ability to do that as well.
Yeah.
And fundamentally we need people who want to do that. I know that Andy and I have had conversations and we thought you and Russell might want to do it.
Sorry.
Yeah, but you know, we're happy. We're open. We're open to everything.
I'd be willing to be one of the people who do that, but I think there needs to be otherwise, you know, a diverse mix.
Yeah. No, I agree. I think that generally the way for our internal systems, the way we run code reviews is people that know that code, or you know, will be the primary contact for a code review. People that know kind of not just the code, but the implication of that code, the semantics of the changes on it. And then, you know, failing that is people that know the language and kind of the systems around it and how it fits together. And then, you know, it's a general discussion. So I think clearly also that the RIAK community is smaller now, but there's certainly people with lots of knowledge in that community around. I know that we've got lots of in-house knowledge. Obviously, the NHS have, ESR, other people that run RIAK every day have got that knowledge. So I think it's just a commitment. Well, not necessarily a commitment, but a willingness to
it's one of those places where process might make sense. You know, to look at what other open source projects do in terms of, do you need 3 reviewers, do you need 2, what has to be gone through before you go? Because, you know, not one of us who run RIAK as part of our business wants to see code deployed detrimental. So I think it's one of those like code review and committing one of those places where I feel like there needs to be enough process around it.
No, I agree.
There can also be a certain degree of decentralization, because if you look at like Linux distros or whatever, right? So you got like benevolent dictator for life and running that organization, and then you've got like various different distros. So you've got like some stuff that's bleeding edge, some that's experimental, some that it's constrained if they want to run it on really small hardware, some that they wanted to have like, you know, features which are very enterprise friendly, like you got a gig of RAM. It's tiny, sorry. But whatever, you know. So you've got like your Arch Linux, it used to break all the time. You got your enterprise Linux, you get your Debian, you get your Debian bleeding edge, your Debian stable, you know, various types. And you know, maybe this will go the same way as well, where you got like maybe some people want their primary focus is to delete 40% of the code base.
Yeah, but for me, I think what you're talking about there is different branches. I mean, there's a canonical branch, then there's Linux. There's a canonical branch, and there's people downstream doing other stuff.
Yeah.
So I think so maybe it does go that. There's got to be process to.
Definitely.
Maybe my question is today, for you the question, do you have a core team, well-identified core developers team that you may give right access to the repository and be sure that they follow the roadmaps, that we can start with that and then
do we?
Yeah, I mean,
maybe 4 or 5 people that you are, or maybe more. I don't know.
Yeah, I mean, at the moment, outside of the 3 of us, I don't know if anyone else who's actually writing code for RIAK.
Is it possible to start with that?
We are.
Yeah.
So it sounds like we have a core team.
Yeah.
People who can submit bits and
Yeah.
do reviews against each other.
I mean, you need to start somewhere and bootstrapping that process with you
So
guys.
let's start with this core team and then
Yeah.
we'll see how to.
We talked a bit about the starting point for release. One thing that we've discussed is the kind of ending point for release. So obviously there are people out there running React 1.4 still, potentially forks of earlier versions as well. And when we start coming to look at React tests, a lot of the React tests are around backwards and forwards compatibility of different versions and this kind of stuff. Now, from our perspective, we're on, I think, minimum 2.0.5, and effectively we plan to go pretty much everything at either 2.2.3 or 2.2.5 within the next sort of 6 to 12 months. Are we moving towards a space whereby we can kind of forget about chunks of the past? Pre version 2 RIAK and that kind of thing. Would that cause great alarm if we were to drop worrying about whether you can still upgrade from 1.4 to 2.2.5?
I don't know. I can find out. I mean, the Danish NHS equivalent is 1.46.
Yeah.
They've been there forever.
Well, they know that they can. We know we've done it ourselves. We know they can go from 1.46. I think we were on 1.48, and we went to 2.05. So there's always that upgrade path.
They did
via
try
one of
them.
They might never upgrade ever.
They've got to get dedicated teams.
It's one of the problems with React, unfortunately, because it works and it's stable, even in early releases, you don't want to change it. You do get inertia there.
Yeah, so we were talking to a 1.4.10 user last night, and we know those people are out there, and we know that there's still a path from 1.4.10 through to 2.0 whatever, but from now going forwards, I guess we kind of prefer to assume that the world started at 2.0.5, and that doesn't stop everyone from going and selecting the tag and going downloading 1.4.10 and playing with it or doing whatever they like with it. But if we get a React test that fails, that's to do with going from 1.4 to React 2.2 or something like that, is that should we really be putting effort in getting that resolved?
I think Basho made it very clear to all these people quite a long time ago that 1.4 was deprecated, that there was no further support, that was the time to upgrade to whatever, to 6, whatever, I forget the exact ones.
Basho we're a community. I mean, if there's community members out there that are stuck.
Look, there's a migration path where you go from ancient to 2.0 whatever, and from there to this. But we don't necessarily need to support the long path.
I agree.
So yes, so is it sensible if we just focus about 2.0 something going forward on the grounds that the legacy maintenance path always exists from 1.4 to 2.0?
And from then onwards they join them.
Yeah.
Regular. Join the club.
Yeah.
At the end of the day, if there are people in the community that want to go from 1.4.10 to 2, then they'll be interested in working on it.
Yeah.
And they can engage with us on a case by case basis.
The people who've done the upgrade can actually be willing to give them advice on how to get to 2.0.
Yeah, absolutely.
I think that involved the praying we were talking about.
Those what?
Praying.
Yeah.
Well, bring some clerics.
All right. So do we think we've got to the ability to create inroads? Anything else that we need to talk about?
I think we agreed that how we're going to get
Oh yeah. I'm not saying it's a solved problem, but it's something that you're going to do.
Yeah. We can talk about things like CI and who's going to commit bits to process that all day long. But I think we're going to find out by doing it.
And I think we'll to a certain extent maybe take a bit of a lead on that from the NHS perspective. But if we keep in touch with Brian and yourselves, then we'll make sure we don't overlap on any efforts there. And then whatever gets produced out of that is open and available. And if at that stage we decide actually it would make life a lot easier if we had a bit of funding for Travis CI or something like that, we'll come along with our begging bowl to you, Martin.
Well, then I'll be paying 4 times for it. With the 3.
Okay, so we've spoken about indexing and replication a couple of times. So I think if everybody agrees, then we should tackle one of those next. So whether people want to break, coffee,
I need a drink before we tackle on that. I mean, I don't mean alcoholic.
Maybe I do. Are we doing indexing or replication, or are we going to decide after the drink?
Yeah, a couple of web services make sense. It's like when you plug it into a relational database, then it's you got a single point of failure. And if you chuck out a lot of stuff and make React smaller, it's faster, run it over more affordable hardware, then it makes sense again.
Okay, so Martin had an open question, indexing forward replication.
We've had a request from Slack.
Okay.
So if you speak up. Yeah.
We've had an issue. We've had a microphone. We've just sourced a microphone from the local map links, which I am told is much better.
Cool. Great.
Is there much chat on the YouTube?
Do we put it up?
Yeah, put up. Should we do that? Is there a way to just only have the chat there? It's kind of weird looking at yourself.
So get some kind of strange feedback loop going on.
Yeah, exactly.
About chat.
Yes.
So I think the last comment is
There
good.
you go.
Perfect.
It's a nice screen.
Yeah.
So we're going to increase that. Okay, do we want to, what do we want to do? Indexing or replication?
Replication.
Yeah, I'm interested in replication.
Oh, I think
It's the best thing to do for that, for people to share what they're interested in about replication. So from our perspective, we know that there are some issues with replication that we manage and deal with operationally, and it doesn't really cause us a problem. The other primary thing that I personally am interested in from a replication perspective is the amount of bandwidth that it uses, because we replicate across the internet, and some of the places that we replicate to and from, their bandwidth charges are less than reasonable, shall we say. And we think that by making the replication more efficient, we will save significant amounts of money. That's something that Andy's been looking at from the R&D side. You've got people looking at replication as well, haven't you, Andy?
Yeah, multiple things. So what replication are you using at the moment? That's so bandwidth heavy. Is that Repl or is that Fullsync?
Yeah, we're using transactional replication, so that real time.
Okay.
Yeah, and we're looking at trying to bring the CRDTs into that, and just replicate much smaller amounts of data. Delta-based.
You want parallel object-based deltas. So you make a change to a CRDT and it only ships the changes that you make to that CRDT to the other side. Is that your game?
That's something that we're looking at the moment. That's something that I've been looking at. It's kind of why I was interested in Russell's big sets. So I've been looking at your white paper of delta-based CRDTs and the reference implementation. But then I'm also interested in your big sets, because I think some of the stuff that we're doing at the replication point to reduce the bandwidth is probably similar to something you've probably already done with delta-based CRDTs and big sets. So I want to have a chat with you really, and what we're trying to do there is exactly that, is just replicate deltas to reduce the bandwidth considerably, because at the moment we're sending all of our objects to these.
Right, so you add an element to a set of 1,000 elements and you send 1,001 elements across, where you should only send one element.
Exactly, yeah.
And to put that in context, some of our bandwidth costs us £500 a megabit, which is crazily expensive, but it is what it is. And we pay more bandwidth. We pay more for a couple of hundred megabits in one location than we do for the other 164 gigabits of aggregated bandwidth that we have in the rest of the world. What about you guys?
So we're replicating between private data centers. So the bandwidth isn't so much a concern. I guess historically, there's
been two primary issues. One of them is reliability of real-time replication, particularly when you get particularly large objects, and the tendency for real-time replication to stop or start going less efficient, and stop using all its nodes and all that kind of stuff. And the other issue is full sync, and I guess the issue is full sync full stop, and in that we abandoned using full sync because we had so many, it didn't quite do what we wanted to do. We had various issues with it, that kind of stuff, and we kind of have a relatively crude DIY solution using secondary indexes at the moment to try and replace full sync. So we want a more efficient way and a faster way of comparing the state of two clusters to make sure that they're in sync and filling the gaps in.
When you say like your range is to like 2i query it based on some point in time, and then get the delta with the other cluster, and then manually like pull it down, ship it off, pull it down, ship it off.
Yeah, so I mean at the moment we have a thing called Delta Touch. I forget what all our different Delta things are called. This one's Delta Touch, and the idea is we use secondary indexes to compare recent changes, and we expand and contract what we consider to be recent over different time intervals. So we kind of check and double check and that kind of stuff. And then when we've worked out what's different, is effectively where we know the side that's ahead of the other side is that we just go and grab the object and put it back in again, so we touch it to prompt it to be real-time replicated. And we want something that's more sophisticated than that. And we have another project that's currently using Fullsync, and I think we previously used key listing Fullsync and had lots and lots of issues with it. We had an experiment using AAE Fullsync and had lots of issues with that. And we have another site that I believe, I can't remember whether they're using key listing or AAE Fullsync at the moment. And their big problem is just the time it takes to validate that both sites are in sync, not necessarily the time to send the delta. So yeah, Fullsync's really where we've got most of the problems, and real-time Repl, it's just really the issue of it occasionally stopping, rather than necessarily, we're not necessarily need to make it more efficient in the same way you do.
Yeah, but I
because
think
the kind of bandwidth between site is cheap.
You've got a lot of objects though, haven't you, Martin, I think?
Yeah, and yeah, so we've got in total across, well, our probably biggest cluster will have about 1 billion objects in. Yeah. Yeah. So full sync across 1 billion objects to make sure they're both connected up is expensive. It's a hard job. It's understandable that it's expensive.
Yeah. And what sort of size are those objects?
They effectively vary from about 4 kilobytes to about 1 megabyte, I would say.
Yeah, there's a definite under 100 kilobytes is about 96%.
Yeah, though we get an interesting pattern whereby the bigger the object, the more likely it is to be updated and get bigger, and the more likely it is to be requested. So some people use the NHS more than others, and if you use it a lot, you get bigger objects, so there's kind of an exponential thing that goes on around object sizes.
I think we worked it out about 80% of the time.
So yeah, 85% of the objects that are less than 100K are accessed, whereas 12-15% of the objects which are more than 100K are accessed 85% of the time. So it's just the opposite to each other.
Yeah, I understand where you're going.
Whereas if you look at overall distribution, you might say actually 85% is less than 100K, so you haven't really got large objects. 5% of the object access every day are larger than 100K.
Okay.
My chairs and objects.
So I was thinking about, tell me if I'm wrong because I'm not in the replication code, but because you talked about the transactional issue, and I was wondering if actually journalization is used for replication, because if we
we implement journalization, it can be used for both for transaction and for efficient replication. So maybe if there is a common task for that, on journalizing the operation, it could help a lot for this.
Generalization, or is like monotonic changes, of course, things like close to that. Is that what stuff does?
You can have partially ordered logs, and partially ordered log is a journal without being.
Are you interested in working on transaction or just interested in feature?
So no, I'm interested in general. But, I mean, the way we're I'm more so we're using React KV and TS at the moment in IoT environments, but I'm coming more from React Core, and what we did is we built a deductive relational graph database on React Core, and the way it works is the database is a ledger. So the way we approach that, so the interesting thing about the indexing is the whole database is an index. So if you know Datomic, if anyone knows Datomic, it's very similar to what we do. So every time you write something into our database, we don't write that. So we write a triple, right? Subject, predicate, object. Alejandro knows Russell. That's the maximum amount of data that you can write. Of course, the object can be a blob, can be a JSON, and so it can be a value of a key value. When you store that in our database, you don't actually store that. I compute all the possible indices of that triple, so the collating orders of that triple, and that's what I store in the database. But the way we store it is an append-only. And when I do that, I create, because I'm not writing a single object, I'm writing multiple objects, I create a transaction ID. And the AAE works on transaction IDs. So if I need to replicate, we don't support multi-cluster replication at the moment, but within React, and even if I do that, I never compare objects, I compare transaction IDs, because that is atomic. So if I write one tuple, I wrote the whole thing. So we have a ledger, and then we compare those transaction IDs in an AAE. If I need to ship, I ship the whole transaction, not the individual objects.
How do you generate the transaction IDs?
We're using, at the moment, we're using Snowflake, kind of. So we're still attached to the wall clock, which is not ideal. And we're moving into, because what we store is a set. That's why it's so interesting in big sets. Because what we have is almost a CRDT. It's not proven to be a CRDT, but it's almost a CRDT. So basically, so what you have is a set of tuples, and everyone is marked with a transaction ID. And if I wrote the first one, I wrote all of the other tuples within that transaction ID. Right. Good. The downside of doing this is obviously you have a lot of data. The beauty of this is relational. So what we have is a query language based on data log that allows you to do deductive queries. So you can do multiple joins, multi-way, which you cannot do in TS, for example.
One of the things that, I don't know if you notice, that one of the things in POC that Basho had been working on was multi-cluster SQL query, cross-cluster SQL queries.
Okay.
Africa, isn't it?
Africa.
Africa.
Yeah. How complete that is, obviously we don't know until we see the code.
Yeah. So our stuff is not open source yet because I have all my savings invested in that. but honestly, we want to open source it. And what we're doing is we're implementing. So it's a query engine, but I could use React KV as opposed. So if I have big sets, I could replace my storage and use React KV for storage. And what I have is another Erlang application on top that allows me to query React KV.
Because you're not using, what are you using for storage then?
I'm using LevelDB and X.
Okay.
So you can have in-memory graphs and that's X. We've been trying to do stuff in NIF, but nothing can beat the speed of X. And then we're using LevelDB with some optimizations that I borrowed from Russell in terms of avoiding serializing. You know, you lose all the, when you serialize Erlang, those terms are not sortable.
This is the sext stuff.
So sext adds 50 microseconds per row. So now I'm not doing sext thanks to Russell, so I'm saving 50 microseconds, which in a query that returns 10,000 rows using 40. But yeah, what we can do at the moment is that query engine is monolithic, so it's like a query in React. You spawn a coordinator in a vnode, and that coordinator coordinates access to data in the other vnodes. So what we do is we send a query, we spawn that coordinator. It has an embedded data flow engine. That data flow starts getting the data from different vnodes. But I'm bringing too much data. The next version, and I already have that optimization, I understand the query and I partition the query in subqueries. If the vnode is a relational database, so it can do joins and projections or whatever, I can push those subqueries to the, so the next step is the vnode is going to be relational, and I'm 50% of that finished. So basically, if I have that, there's nothing stopping me from saying, I'm not targeting the vnode, I'm targeting clusters. So I have a query engine that can actually talk to vnodes or talk to clusters.
Job coordinator.
Yeah. Yeah, but yeah, so it has a bunch of the typical database SQL optimization. So for me indexing, the way we treat it, and now that there are more into React KV, and we are, I think at the moment we are abusing Solr, and we shouldn't. But the more I look at it, is maybe it's some of what we do in LSE, and what I think you're probably talking about level, is how you can do secondary indices. And the question is always going to be, are they transactional or not? Because you write the object and then you write the indices in separate. And that's why I was thinking about transactions and all of this. So yeah.
So are we done with replication?
Yeah, we got distracted by a really interesting topic there. It was very, very interesting.
I guess I was interested, you mentioned about the sort of known issues around replication.
Yeah.
So what from your perspective, the big things, so when you say known issues, is that aside from the bandwidth issues, that actually?
Yeah, so I think it's things like that you touched on there, that real-time replication stops.
Yeah.
We see huge queues build up. I think you touched on it, that nodes will lose connection to the here on the side, and then we end up, unbalanced, performance drops. You end up turning it off and on again to bring everything back in line. I think for us, I think as Martin mentioned, we cope with them operational by turning it off and on again. We want to stop doing that. So I think those are the known issues that we want to fix. And I think there's stuff like head leakage, process leakage within the cluster. There's
something that stops you from stopping a node.
Exactly. Yeah. So we've got a job cron that goes and culls that list periodically. So it's all these things that we want to stop having to do those daily tasks.
Martin working on that, fixing the underlying root cause.
Well, that's in the out of this roadmap. That's what we get to. What's the path through that? But that's on the works now.
On the replication, is there any requirements for things like selective replication or traffic shaping?
Yeah, for us, so I mean, there is some configuration, but fine grained configuration would be good for us.
If you come back to your thing, right, where you want to ship operations, like if you're modifying CRDT in cluster A and you got like actor IDs and stuff, right, with the V clocks on it, and you get the CRDT in cluster B, you get a separate set of actor IDs in its V clock. You ship the operation from cluster A to cluster B. The two objects, if you do like a comparison of them, they're not a match, right?
An operation's different to deltas. Deltas have the ID and the actor inside them. So one of the promises of RIAK is that your actor IDs are globally unique even across multiple clusters.
Yeah.
So that the cost of multiple clusters is larger larger logical blocks.
So you can't say, well, I did a change to this CRDT here, right? And you got like a post commit hook or something on that bucket. Something happens, you put an operation in, it takes that operation, sends that operation to the far side, it's applied to an object on the far side, okay? Right, that's cool. So this is just real-time replication. Then it comes to Fullsync operation, and you're comparing the two objects against each other. They both got the same set of operations, but they got different V clocks. So you got the difference, and you still got to ship it.
That's what I'm saying. For operation-based CRDTs made, but they don't have these.
They don't exist, right?
But
yeah, well, I mean, they're not in there.
Someone watching there will tell you you're wrong.
No, I know that they exist, but it's not been implemented.
But
the React ones are all state-based.
The delta stuff is a delta of the state. So you know, in the case of a set or something, it's the actor and the event and the data.
Yeah.
So that actor gets incorporated in the version vector on the other side. So it's the same actor and the same operation. So they end up with the same state. So that's the whole point of deltas, is to get an equivalent, we end up with the same state.
So I think we feel we need to do.
Yeah.
Yeah. And now we've got a partial prototype which is currently doing that.
So we've got current replication. So we've got current real-time replication, current full sync, and then we've got this Andy's pie in the sky at the moment.
Do you call it like delta replication?
It's not got the point where it gets a grand name at the moment.
It's still in R&D, so call it what we want.
It's I mean, if we want, are we looking to effectively we're looking for somebody to say we'll fix it, and are you saying that we'll fix it?
Yes.
Yeah. So effectively, what we're saying is we'll sort out the replication side in terms of existing replication.
Can we talk about the existing replication code as if it's open source at the moment, do you think?
Yes, I believe so, yes.
So, because I think there's a couple of approaches to fixing replication. One of them is to go and look at the other code and look at the current code and try and improve it. So there's the known bugs in it. There's also some interesting aspects about how it works. Yeah. So, for instance, you know, when you do a full sync, it's if you're doing a full sync with a key listing full sync, it's a comparison of keys and hashes. In order to get the hash, it does a fold object. So it's called key listing, but the one thing it doesn't do is list keys. It folds objects, and each object, it takes the object off the disk. It does an object from binary to convert it into a RIAK object record. It takes the vector clock out of the object, it sorts the vector clock, it puts the vector clock back in the object, it does a 2 binary, yeah, and then it does a hash of that to generate the key in the hash. Now that's done for good reasons, we believe, and I think they're largely historic reasons to do with old style vector clocks and problems with clashes and that kind of stuff. But that's a kind of an example area where the current code is, you know, if we can forget some of the past, you know, we could clean it up. The AE type full sync, we think, but we're not sure at the moment.
Is this the one that's using Merkle trees?
Yeah, the one that's using the current AE Merkle trees to do a full synchronization. That has a thing whereby, so if you do key listing on Merkle trees, they get to the state of doing effectively a key and hash comparison. And it then, if you're doing key listing style full sync, it then, from the keys that are differed, it generates a bloom filter. And it then basically sends the bloom filter to whatever side is the source. So it doesn't care which side is most up to date. It says, the keys differ, you might be the out-of-date one, yeah, but I'm going to send you the bloom filter with that key in. And then it does another fold objects, yeah, in key listing, and it folds over all the objects again, looking for keys that match in the bloom filter. If it finds a match, it sends it across to the other side. And obviously, you might be the out-of-date side, yeah, but you'll just send over the out-of-date object, and the other side will remember it, will discard it, yeah. But it does mean that you've got to do a second full fold across the vnode, also you're half the time you're sending the object unnecessarily because you're sending it from the out-of-date side to the update side. The AAE version has a little twist on that, whereby we think what it does is, as it discovers the discrepancies, it does them one by one. So it says, oh, I've discovered this key, this discrepancy, go and send that across, go and send that across, go and send that across. Until it's got to such a point where it's gone, you know what, I've sent 5% across now, and this is probably not the most efficient way of doing it. So then it generates a bloom filter, and then it does a fold over all the objects. So if you've got 5.01% need to be sent across, it'll do 5% through random reads, and then do a fold across all the objects to get the remaining 0.1% across. So there's potentially some areas in the existing code that we can address and perhaps need some looking at and some improvements.
Shall on this then, do you think a good thing would be to document the way the existing replication works in different ways, and then propose what we would see as a good solution for it?
Yeah.
And then if Martin's up for it,
yeah,
he can do it.
Yeah, and I think one of the things that we would be citing back, for example, with real-time replication, is that the current replication does a lot of work at the moment around managing connection pools and this kind of stuff, and generating queues and this sort of stuff. So we looked at using, well, can we simplify that by using an off-the-shelf queuing product and get that to do the job instead. So I think at some stage it'd be interesting to talk about is how long do we kind of try and resolve the problems by fixing the current code, or would it be better to say, is there a simpler way of resolving this by, as we've done, introducing Rabbit into the equation on the basis that has some of these issues, of replicating between two different queues and this kind of stuff, allowing multiple consumers of the same queue and all that kind of stuff. That has some of these problems resolved, and should we be using that rather than trying to do our own TCP connection management and queue management within the code? So I mean, it's not to say that you can see why Basho did that at the time, but should we now be looking to potentially have a different type of replication, try and resolve the problems in a fundamentally different way?
Yeah, no, I agree. And I think those two activities can happen in parallel.
Yeah.
We can, I want to say, shore up the existing replication, and then we can look at these various ways forward. But if we do it together, those ways forward, we're not going to duplicate everything.
Yeah.
Yeah, I mean, we did look at Kafka, yeah, actually. We didn't find that performant.
We did something, well, I think we've overlapped a little bit, and again, where we could collaborate is that at the same sort of time that you did Rabl, I think, in R&D we did a prototype of replacing real-time replication. We did Solace, Kafka, and Rabbit, same sort of thing, and it's very similar to what you've got on your GitHub repo. And it's the same sort of thing. Yeah, and I was fortunate enough that when mine purchased the source code, I could go through the source code and look at it, and it came to the exact conclusion that you did. That it's basically, this is doing all of the work of a message broker. It's doing all the things of a message broker, perhaps not quite as well as what a message broker would do. And my thoughts at that time is that you'd be able to use a message broker to do that, and then RIAK concentrate on what it's going to do.
Yeah, I have mixed feelings personally, because I mean, Rabbit's a bit of a beast in its own right. I think on the one hand, it's creates a tool to do a job. And keep it simple in the individual tools. But then on the other hand, you bring in another really complex product into a solution, aren't you?
Yeah, and I mean, in terms of performance, I think we came to the conclusion that any of the brokers could keep up with the load that we threw out in stress tests. So any of them were suitable, but yes, you have the added complexity of that.
To what extent was your stress testing realistic for our workloads?
Yeah, for our workloads. Yeah.
For our workloads.
So Solace was obviously the quickest, but then it's closed source and expensive.
Yeah,
products.
it's an appliance, Solace is.
And so that's when we looked at Rabbit and Kafka, and both are capable, but we were looking at Kafka for
Sorry. So Kafka's a Apache Java
distributed log.
Distributed log, yeah. And it offers at least once guarantee that something's going to.
Well, it now offers exactly once.
Exactly once, right.
As well in the latest version.
Well, the performance impacts of that.
Yeah, because you have a transaction in the broker.
Yeah. So I think what we're saying is we'll sort out the existing replication in situ, and then we'll loop together to come up with some kind of proposal as to what to do moving forward with replication, whether it's just taking it out or if it's fixed. I mean, I don't know how nasty the code is.
well, my thought was to take it out, but I mean,
yeah, he hasn't got a real job.
There is always like, I mean, just you could derive this from the nature of your business rather than any knowledge from here. But there's also the question that you don't necessarily want to replicate everything as well. You want selective replications, different locations, and that's quite a lot of logic to stick into the cluster replication logic.
Yeah, yeah.
Like you need flexibility there. There's another thing, you need filtering, and maybe you need other mechanisms.
So what if you could replicate by bucket, for example?
Yeah.
To set mine up with a
So the other thing that we've been working on is splitting out the job of Fullsync into two parts. One of them is near real-time synchronization. So have things that got written recently being sent across on the grounds that that's a simpler job than, particularly when you've got a billion objects in the cluster, is everything the same? Yeah. And what we've been trying to do is find ways of doing that with coverage faults. So at the moment, Fullsync replication is done vnode by vnode, so it creates this issue that you've got to have consistent cluster sizes between the two things. And also means that if you ever wanted to use the same kind of code to replicate with something else, like solar, you've kind of got to think about, vnodes, rather than, which might be inconsistent with how that different database technology work. Whereas if it's just a case of cluster to cluster, that will make more sense in different contexts. So we're trying to write. I've got a thing called map folds at the moment, and you can. I've got a different version of Merkle tree that I've sort of termed a tic-tac tree. It's actually used in Cassandra as well, but basically it's a Merkle tree, but it's not cryptographically strong. Because actually we're exchanging between trusted actors, so we don't care about the cryptographic strength. But what we want to be able to do, we want to be able to build a Merkle tree incrementally and merge Merkle trees. And because with these trees we can build them incrementally and merge them, that means if you want to do a comparison, we can actually fold over a coverage plan, merge the outcome across vnodes, and send something that's just the size of the tree over the wire, and then do the same thing on the other side, and we can actually compare both sides and only have to exchange something the size of the tree over the wire. And it doesn't matter if one side has got one ring size and another side has got another ring size. And those same Merkle trees, we can pass them, so at the moment we've got it so we can pass it over an object fold that's done by bucket, or that's done by a key range in a bucket. Hopefully in the next week or so, I'll have it for doing it across indexes, so we can set up a secondary index of, based on last modified date. I've got it working level DB backend, so level A backend, so we can auto expire index entries after a certain time, so they naturally delete after, let's say, 24 hours, so you don't keep that around. And so if we can then say, right, okay, well, tell me what the changes that have occurred in the last hour are consistent between these clusters. And it's the same thing, you do a coverage plan, Merkle tree, a coverage plan, Merkle tree, compare the two, and then you have to follow that up. You might get a list of segments within the Merkle tree that have changed, and you're going to say, well, what's the keys and clocks for those segments? And then compare the keys and clocks, and then say, right, that side's up to date, and that side's behind. I need to go and
and replicate across there. So we're hoping that, and obviously, you know, we can do that over an index. So if we've got two indexes on two sides, we can see if those indexes are consistent as well as the objects are consistent. And but potentially, you know, because it's a function, you know, we could apply whatever qualifying function to the object or the key that we decide. If we want to say, well, actually, selective, all I really care about is objects of this type in this bucket. Are they consistent at the moment? And you could kind of do something like that. So, you know, I think that's a potentially interesting building block for Fullsync going forward. And also, I think it's interesting to start thinking about Fullsync as split between two problems. And in particular, if we've got a near real-time synchronization, it takes a lot of the pressure out of reliability of the real-time queue. Yeah. So at the moment, there's a kind of lot of retry stuff in real time, and so to make sure it gets across, because like you know, you really don't want to run Fullsync too often. Yeah. But if we can run a near real-time thing, you know, every 5-10 minutes, yeah, then we can be looser about how we real-time replicate and have less complexity in real-time replication. You know, so we chose to use Rabbit. We thought, well, we don't need to worry about clustering it and all this kind of stuff, because actually, if we lose something, and if we've got near real-time Fullsync that's really cheap and quick to run, then we can pull it across very quickly afterwards. And so, you know, if we get something that would otherwise block real-time replication, it can be discarded because we've got another mechanism of discovering that without waiting for an overnight kind of Fullsync job. So I think we're hopeful at the moment that that kind of difference in approach is potentially a building block for a much simpler overall package of replication options.
Yeah, that's interesting. I think
that's exactly what Jeff's been looking. Well, very similar to what Jeff's been looking. So our colleague Jeff Keane, he's been looking at backend and buckets and how we can build in the same sort of process, same sort of way, cryptographically weak Merkle trees, and do exactly that. And that's
yeah, I think what we don't want to do is we don't really want to overlap on what we're doing there.
Yeah, it's very similar.
I think if you know if you want to concentrate on the Fullsync and the near real-time stuff, we look at the real-time stuff because we're more interested in that. Our latency requirements are potentially different than yours, and then we've got a good split there. If you want to do that, and then Andy can carry on with his magic fairy dust.
Yeah, I mean, I guess we could probably talk a lot longer about replication. Is it worth that we actually have a separate dedicated NHS follow-up for a day or two between some R&D groups to?
Because I think what we want to be clear about, I think, is that we want a solution that's fit for purpose, or solutions that are fit for purpose for everybody.
Yeah.
And we want to make sure that we're not duplicating work and so on and so forth. I think are the key things. So yeah, we can do that.
Is there anything else you want to talk about in regards to replication in general?
Yeah. So on the Rabbit side of things, I think I had a look at Russell's work. They're using the Shovel plugin.
No. You can if you want to, but no, we're not using it.
Okay. So what are you using it like to take messages from
Yeah, so the clients, we're directly connecting from clients on one cluster to the queue on the other cluster. So there's a separate Rabbit instance.
You can configure it how you like.
Yeah.
We tried two different ways. One way we've got a Rabbit cluster on one cluster, a Rabbit cluster on the other, Shovel between the two. Yeah. And that's slow.
Okay.
Because Shovel is a single client.
Yeah.
It takes a block and that's business across.
Yeah.
What we did instead is we did it more like React real time. We had each React node gets a Rabbit node. Yeah. And have a local queue that's named after that node. And each remote Rabbit, each remote React node has an array of consumers that pull from the selection of remote Rabbit node processes. So that's gone much better.
Because I discussed something with Brian, which I want to try out. So on Rabbit, you also got this federation plugin.
Yeah.
I don't know if you ever look at that. So you can actually federate exchanges.
Yeah, I know that was written by Alvaro, wasn't it? And he was saying to have a look at that when I was looking at that. So.
Okay.
But again, the federation's done the same way by a single client to move lots of keys across. Ultimately,
But you can publish to multiple.
Ultimately, when it comes down to it,
yeah.
you have it's TCP/IP, which is stuff around.
Yeah.
So we just did it as simple as possible. So the way Rabl's written is how you configure Rabbit is entirely up to you. From a different federation. All you tell Rabl is this is the queue I publish to.
Yeah.
This is the queue I read from. How the get between those keys is really up to you. So you don't do it. You can do it. Federation or shuffle or just direct.
Is anyone doing any complex chaining of replication? So, cluster A to B to C to D?
Yeah, we do.
You do.
So by using a pub sub approach, you can have the multiple consumers in the same queue. Right?
Yeah, we're currently replicating twice. So we do replication within one location between two data centers over dark fiber, then across the internet. But that's going to get significantly more complex as we bring more data centers online. So we've got another 3 or 4 coming online in the next 12 months, and I think we'll end up with all of them having copies of the data. But we don't use bidirectional. It's all unidirectional. We don't use bidirectional at all.
Right. So we tend to be bidirectional between two sites.
Yeah.
Potential use case to then also go to another cluster as well. Partly because we didn't put backup on here, but that's all there is problems backing.
Yet another thing that was in the proof of concept, you may not have noticed, is hot backup.
I missed this earlier, I'm sorry that I missed the answer. You don't use Fullsync at all, but you're entirely real-time record?
We do use Fullsync in places. Primarily when things go wrong.
Yeah.
So it's a backup for real-time.
Is that key listing for Fullsync? It does list keys?
Yes. And yeah.
All right, so we'll that's great. We'll get together around replication and flesh that out further. Do we want to break for lunch now, and then we'll get into indexing and search afterwards?
Yeah.